Picture this. You're walking along a quiet country road in modern-day England, your footsteps echoing against weathered stones that have witnessed the march of Roman legions, the gallop of medieval knights, and the passage of countless travelers across 2 millennia. The road beneath your feet isn't just any road, it's a testament to engineering genius that has outlasted empires, survived wars, and continues to serve travelers today, just as it did when Julius Caesar's soldiers first laid these very stones over 2,000 years ago. Before we embark on this incredible journey through time to uncover the secrets of Roman road construction, make sure to hit that like button and subscribe to our channel. Because once you close this video, the mysterious algorithms of the internet might never show you our content again. And you'll miss out on more fascinating stories from the ancient world that will change how you see the infrastructure around you forever. The story of Roman roads begins not with grand proclamations or imperial decrees, but with a simple, almost mundane problem that would eventually reshape the entire ancient world. In the early days of the Roman Republic, around the 4th century BCE, Rome was just one city-state among many in the Italian peninsula, surrounded by hostile neighbors and connected to the outside world by little more than dirt paths and animal tracks that became impassable mud pits during the rainy season and choking dust clouds during the dry months. Imagine being a Roman merchant in those days, trying to transport goods from Rome to the growing settlements scattered across the Italian countryside. Your ox cart, loaded with precious cargo, would get stuck in the mud for days during winter storms, or you'd find yourself lost on poorly marked trails that seemed to change direction with every seasonal flood. Worse still, these primitive roads were perfect places for bandits to ambush travelers, knowing that anyone attempting to flee would be slowed by the treacherous terrain. The Romans, being the practical and militaristic people they were, quickly realized that their ambitions of expansion and control would be impossible without a reliable way to move their armies, supplies, and communications across vast distances. But they didn't just want to build roads. They wanted to build roads that would last forever, roads that would carry the weight of their legions and the burden of their empire without cracking, without washing away, without becoming impassable during the changing seasons. What makes this story even more remarkable is that the Romans had no modern machinery, no concrete mixers, no steam-powered equipment, and no advanced metallurgy. They had only human muscle, animal power, and an almost obsessive attention to detail that bordered on the fanatical. Yet somehow, using nothing but these primitive tools and an engineering philosophy that prioritized permanence over speed, they created a road network that would span from the misty hills of northern Britain to the sun-baked deserts of North Africa, from the Atlantic shores of Portugal to the mountains of Armenia. The Roman approach to road building was so systematic and so effective that many of their construction techniques remained virtually unchanged for over 1,000 years after the fall of the empire. Even today, modern engineers study Roman road construction methods, not as historical curiosities, but as practical solutions to contemporary infrastructure challenges. The Romans understood something that many modern builders have forgotten: that the most expensive road is not the one that costs the most to build, but the one that requires constant repair and reconstruction. To understand how the Romans achieved this remarkable feat of engineering, we need to go back to the very beginning, to the construction of the first great Roman road, the Via Appia, or the Appian Way. built starting in 312 BCE under the supervision of the censor Appius Claudius Caecus. This road was intended to connect Rome to the important city of Capua, about 130 miles to the southeast. But the Via Appia was far more than just a transportation route. It was a statement of Roman power, a demonstration of their engineering capabilities, and a strategic military asset that would prove crucial in their wars against the Samnites and other Italian tribes. The construction of the Via Appia began with what might seem like an impossibly ambitious surveying project. Roman engineers, working with primitive tools that would make modern surveyors weep with frustration, managed to chart a route that was not only remarkably straight, but also took advantage of the natural topography to minimize steep grades and avoid major obstacles. They used a device called a groma, essentially a cross-shaped wooden frame with plumb lines hanging from each arm, to establish right angles and maintain straight lines across the landscape. But the real genius of Roman road construction lay not in the surveying, impressive as that was, but in the layered construction method that gave their roads incredible strength and longevity. The Romans didn't just lay stones on top of the ground and hope for the best. Instead, they developed a sophisticated multi-layer system that distributed weight, provided drainage, and created a road surface that could withstand the pounding of military boots, the weight of loaded wagons, and the relentless assault of weather for centuries. The process began with the most back-breaking labor imaginable. Roman work crews, composed primarily of soldiers during military campaigns or slaves and hired laborers during peacetime, would dig a trench along the entire route of the proposed road. This wasn't a shallow scraping of the topsoil. It was a deep excavation that removed all organic material, loose soil, and anything else that might compress, shift, or decay over time. The depth of this excavation varied depending on the terrain and the expected traffic, but it was typically between 3 and 5 feet deep, and sometimes even deeper in areas with soft or unstable soil. The width of this excavation was carefully calculated based on the intended use of the road. A major military highway might require a roadway wide enough for 2 military columns to pass each other comfortably, while a local road might be designed for single-file traffic with occasional passing areas. But regardless of the final width, the excavation always extended well beyond the edges of the finished road surface, creating space for drainage ditches and preventing water from pooling against the road structure. Once the excavation was complete, the real construction could begin. The Romans understood that the secret to a lasting road lay in its foundation, and they approached this foundation with the same meticulous care that they applied to the construction of their greatest temples and monuments. The first layer, called the statumen, consisted of large flat stones, often limestone or basalt, carefully fitted together to create a stable base. These stones were typically 12 to 18 inches thick and were placed with their flattest surfaces facing up to provide a solid platform for the layers above. The selection and placement of these foundation stones was not a random process. Roman engineers would personally inspect each stone, rejecting any that showed signs of weakness, cracks, or weathering. The stones were then carefully positioned to interlock with their neighbors, creating a foundation that was essentially a giant stone puzzle, held together by precision fitting rather than mortar. This technique, known as opus quadratum, when used in building construction, required skilled stonemasons who could shape each stone to fit perfectly with its neighbors. But the Romans didn't stop with a single layer of foundation stones. On top of the statumen, they placed a second layer called the rudus. consisting of smaller stones, typically 6 to 12 inches in diameter, mixed with mortar made from lime, sand, and water. This layer served multiple purposes. It filled any gaps between the foundation stones, provided a more level surface for the next layer, and created a slightly flexible interface that could absorb some of the shock from heavy traffic without transmitting it directly to the rigid foundation below. The mortar used in the Rudis was not the quick-setting cement we're familiar with today, but a lime-based mixture that set slowly and actually grew stronger over time as it absorbed carbon dioxide from the air. This mortar was mixed with volcanic ash when it was available, creating a concrete that was waterproof and incredibly durable. The Romans had discovered that certain types of volcanic ash, particularly the pozzolan found near Naples, could create a concrete that would actually set underwater and become harder than stone. Above the Rudis came the third layer, called the nucleus, which consisted of smaller stones, gravel and sand, again mixed with mortar. This layer was typically 6 to 12 inches thick and served to create a smooth, level surface that could support the final road surface. The nucleus was carefully graded and compacted, often using heavy stone rollers pulled by oxen or teams of workers with wooden tampers. The final layer, the one that travelers would actually walk or ride on, was called the summum dorsum or summa crusta. This surface layer was where the Romans truly showed their mastery of stonework. For major roads, this layer consisted of carefully cut stone blocks, often made from hard volcanic rock like basalt or trachyte, fitted together with gaps so tight that you couldn't slide a knife blade between them. These blocks were typically hexagonal or polygonal in shape, allowing them to fit together like a giant stone jigsaw puzzle that distributed weight evenly across the entire surface. The cutting and fitting of these surface stones required incredible skill and patience. Each stone was shaped by hand using iron tools, with stonemasons working to tolerances that would impress modern craftsmen. The stones were cut so precisely that they required no mortar to hold them in place. They were held by friction and the perfect fit of their interlocking edges. This technique, known as opus polygonale, created a surface that was not only incredibly durable, but also beautiful, with the natural variations in stone color and texture creating patterns that turned each road into a work of art. But the Romans understood that even the most perfectly constructed road would fail if water was allowed to undermine its foundations. Roman engineers were obsessed with drainage, and they incorporated sophisticated water management systems into every road they built. The road surface was deliberately curved or cambered, with the center slightly higher than the edges, causing rainwater to run off to the sides rather than pooling on the surface. Along the edges of the road, the Romans constructed drainage ditches, called fossae, that carried water away from the road structure. These ditches were not simple trenches, but carefully engineered channels, with sloped sides and, in many cases, stone linings to prevent erosion. The ditches were connected to larger drainage systems that carried water to natural water courses or specially constructed reservoirs. In areas where the road had to cross streams or rivers, the Romans built bridges that were engineering marvels in their own right. These bridges were constructed using the same principles as their roads: multiple layers of carefully fitted stones, no reliance on mortar for structural integrity, and obsessive attention to drainage. Many Roman bridges are still in use today, carrying modern traffic loads that their builders could never have imagined. The construction of these roads required an enormous workforce, and the Romans organized their construction crews with the same military precision they applied to their legions. A typical road construction project would involve hundreds or even thousands of workers, organized into specialized teams. Some teams would be responsible for surveying and marking the route, others for excavation, still others for quarrying and transporting stones, and finally, the skilled stonemasons who would cut and fit the surface blocks. The logistics of these construction projects were staggering. Consider the Via Appia, which required an estimated 80,000 tons of stone for its original 130-mile length. This stone had to be quarried from specific locations where the rock had the right properties, then transported to the construction site using ox carts, river barges, or human labor. The limestone for the foundation stones might come from quarries dozens of miles away, while the basalt for the surface might come from volcanic areas even further distant. The Romans developed sophisticated techniques for moving these massive stones. They used wooden rollers, ramps, pulleys, and levers to move blocks weighing several tons each. They also developed specialized carts with wooden wheels that could carry heavy loads over rough terrain. The organization required to coordinate all these moving parts, the quarrying, transportation, and construction crews, was a logistical achievement that rivaled their military campaigns. But perhaps the most remarkable aspect of Roman road construction was the speed at which they could build these incredibly sophisticated structures. Historical records suggest that a well-organized Roman construction crew could complete about 1 mile of major road per month, including all the excavation, layer construction, and stone fitting. This might seem slow by modern standards, but consider that they were creating roads that would last for millennia, not decades. The Romans also developed standardized construction techniques that could be adapted to different terrain and conditions. In marshy areas, they would build raised causeways, sometimes driving wooden piles deep into the soft ground to create a stable foundation. In mountainous regions, they would cut roads directly into the living rock, creating passages that followed the natural contours of the land while maintaining the gentlest possible grades. One of the most impressive examples of Roman road engineering in difficult terrain is the portion of the Via Appia that crosses the Pontine Marshes, a swampy area southeast of Rome that was considered impassable by earlier civilizations. The Romans built a raised causeway across this marsh, supported by thousands of wooden piles driven deep into the soft ground. This causeway, parts of which are still visible today, allowed travelers to cross the marshes in comfort and safety, turning a dangerous and time-consuming journey into a routine trip. The construction of Roman roads was not just an engineering project, but also a social and economic transformation. As the roads spread across the Italian peninsula and eventually throughout the Roman Empire, they brought with them profound changes in how people lived, worked, and thought about the world around them. Before the Roman roads, most people lived their entire lives within a few miles of where they were born. Travel was dangerous, difficult, and time-consuming, and most communities were largely self-sufficient by necessity. The Roman roads changed all of this. Suddenly, it became possible to travel hundreds of miles in relative safety and comfort. Merchants could transport goods across vast distances, opening up new markets and creating economic opportunities that had never existed before. The roads also facilitated the rapid movement of information. The Romans developed an efficient postal system called the cursus publicus that used relay stations along the major roads to carry official messages across the empire. A message could travel from Rome to the English Channel in as little as 40 days, a speed of communication that would not be matched again until the invention of the telegraph. But the roads were perhaps most important for military purposes. Roman armies could move with unprecedented speed and efficiency, allowing them to respond quickly to threats anywhere in their territory. The roads also allowed for the rapid deployment of reinforcements and supplies, making it possible for relatively small garrison forces to control vast territories with the knowledge that help was never more than a few weeks away. The psychological impact of the roads was equally important. The sight of a perfectly straight, beautifully constructed Roman road stretching to the horizon was a powerful symbol of Roman power and civilization. Local populations could see for themselves the superiority of Roman engineering and organization, and many were impressed enough to willingly accept Roman rule rather than face the military forces that could move so quickly along these roads. As the Roman Empire expanded, the road network grew with it. By the height of the empire in the 2nd century CE, the Roman road system included over 250,000 miles of roads, reaching from Hadrian's Wall in northern England to the Sahara Desert in North Africa, from the Atlantic coast of Portugal to the Euphrates River in modern-day Iraq. This was not just a collection of individual roads, but a true network, with major highways connecting all the important cities and strategic locations throughout the empire. The Romans developed a sophisticated system for maintaining this vast network. They established a corps of road inspectors who traveled the roads regularly, checking for damage and coordinating repairs. They also required local communities to contribute labor and materials for road maintenance, creating a system that distributed the cost of upkeep across the entire empire. The techniques used for road maintenance were almost as sophisticated as those used for original construction. Roman engineers developed methods for replacing damaged surface stones without disturbing the underlying layers, and they created portable workshops that could move along the roads, providing tools and materials for repair crews. They also developed techniques for strengthening existing roads to handle increased traffic, often by adding additional layers or widening the roadway. The Romans also pioneered many of the traffic management techniques that we still use today. They established rules for right-of-way, with military traffic having priority over civilian traffic, and they created rest areas and way stations where travelers could find food, shelter, and fresh horses. They even developed an early form of traffic control, with officials stationed at busy intersections to direct the flow of traffic and prevent congestion. The Roman road system also included sophisticated signage and mapping systems. Stone markers, called milestones, were placed at regular intervals along the roads, providing information about distances to major cities and sometimes including messages from the emperor or local officials. These milestones were not just functional, but also served as propaganda tools, reminding travelers of the power and reach of the Roman state. The Romans also created detailed maps of their road network, including the famous Tabula Peutingeriana, a strip map that showed the entire Roman world with roads, cities, and important landmarks. This map, which survives in medieval copies, was an essential tool for travelers and military commanders, providing detailed information about routes, distances, and available services. But perhaps the most remarkable aspect of the Roman road system was its longevity. Long after the fall of the Roman Empire in the 5th century CE, the roads continued to serve the peoples of Europe, North Africa, and the Middle East. Medieval travelers followed the same routes that had been established by Roman engineers 1,000 years earlier, and many of these routes remained the primary transportation corridors well into the modern era. The reasons for this longevity go beyond just the superior construction techniques used by the Romans. The Romans had chosen their routes with remarkable foresight, connecting the most important cities and strategic locations in ways that remained relevant for centuries. They had also built their roads to last, using construction techniques that created structures capable of withstanding not just the immediate loads they were designed for, but also the accumulated wear and tear of centuries of use. Today, nearly 2,000 years after the height of the Roman Empire, many Roman roads are still in use. The Via Appia, the first great Roman road, still carries traffic between Rome and the cities of southern Italy. Portions of it are now modern highways, but in many places, travelers can still walk or drive on the original Roman stones, experiencing the same smooth, durable surface that carried Roman legions, medieval pilgrims, and Renaissance merchants. In Britain, many of the major roads still follow routes established by the Romans. Watling Street, the great Roman road that connected London to Wales, survives today as the A5 highway. Ermine Street, which connected London to York, became the A1, one of Britain's most important north-south routes. Fosse Way, the Roman road that ran from Exeter to Lincoln, still carries traffic across the English countryside, and in many places, modern travellers can see the original Roman roadway alongside the modern highway. The influence of Roman road construction extends far beyond the roads themselves. The techniques developed by Roman engineers influenced construction practices throughout the Middle Ages and into the modern era. The use of multiple layers, careful attention to drainage, and the principle of building for permanence, rather than just immediate needs, became standard practices in construction projects throughout Europe. The Romans also established many of the legal and administrative frameworks that govern transportation infrastructure today. The concept of public roads maintained by government authority, the use of tolls and taxes to fund road construction and maintenance, and the establishment of right-of-way laws all have their origins in Roman practice. Modern engineers continue to study Roman road construction techniques, not as historical curiosities, but as practical solutions to contemporary problems. The Roman emphasis on proper drainage, for example, has been rediscovered by modern engineers dealing with road failure in areas with heavy rainfall. The Roman technique of using multiple layers with different properties has influenced modern pavement design, and the Roman principle of building for longevity has gained new relevance in an era of increasing concern about the environmental costs of constant reconstruction. The story of Roman road construction is ultimately a story about the power of human ingenuity and determination. The Romans faced challenges that would daunt modern engineers. They had to build roads across hostile territory, using primitive tools and unreliable transportation, while under constant threat from enemies who wanted to prevent their expansion. Yet they not only overcame these challenges, but created infrastructure that has outlasted their empire by more than a millennium. The Romans succeeded because they understood that infrastructure is not just about moving people and goods from one place to another. It's about creating connections that bind communities together, facilitate commerce, and project power. They built their roads not just to meet immediate needs, but to create lasting foundations for civilization itself. The techniques they developed, careful surveying, multi-layered construction, obsessive attention to drainage, and building for permanence, are principles that remain relevant today. In an era when much of our infrastructure is designed for obsolescence, With roads that need constant repair and rebuilding, the Roman example reminds us that it is possible to build things that last. But perhaps the most important lesson from the Roman road builders is about the relationship between infrastructure and civilization. The Romans understood that good roads were not just a luxury for the wealthy or a convenience for travelers. They were essential foundations for economic growth, social cohesion, and political stability. Their willingness to invest enormous resources in road construction, even when the immediate benefits were not always clear, created a network that generated wealth and prosperity for centuries. The Roman roads also demonstrate the importance of standardization and systematic approaches to infrastructure development. Rather than building each road as a unique project, the Romans developed standardized techniques that could be adapted to different conditions while maintaining consistent quality. This allowed them to build their vast network efficiently and ensure that roads built in different regions would have similar performance characteristics. The legacy of Roman road construction extends far beyond the physical roads themselves. The Roman approach to infrastructure development, careful planning, quality construction, systematic maintenance, and building for the long term established principles that continue to influence how we think about infrastructure today. Their example reminds us that infrastructure is not just about immediate convenience, but about creating the foundations for long-term prosperity and stability. As we face our own infrastructure challenges in the 21st century, the Roman road builders offer both inspiration and practical guidance. Their techniques for dealing with difficult terrain, their methods for ensuring durability, and their systematic approach to network development all have relevance for modern engineers and planners. But perhaps most importantly, their example reminds us that great infrastructure requires not just technical skill, but also vision, commitment, and the willingness to invest in the future. The next time you drive on a highway, walk on a paved street, or use any form of modern transportation infrastructure, remember the Roman road builders who, 2,000 years ago, established the principles and techniques that still guide construction today. Their legacy is not just in the stones they laid or the routes they chose, but in the understanding that infrastructure is one of the most important investments a civilization can make. The Roman roads stand as monuments to human ingenuity, persistence, and vision. They remind us that with careful planning, skilled craftsmanship, and the willingness to invest in quality, it is possible to build things that will serve not just our own generation, but countless generations to come. In a world where so much is designed to be temporary, the Roman roads stand as enduring proof that some things can indeed be built to last forever. And so, as you settle into sleep tonight, let your mind wander along those ancient Roman roads, imagining the countless footsteps that have worn smooth those carefully fitted stones, the countless journeys that have been made possible by the vision and skill of those long-dead engineers. Picture the Roman surveyor with his groma, carefully marking the route that millions would follow. See the work crews laboring in the sun, fitting each stone with painstaking precision. Imagine the first travelers on the completed road, marveling at the smooth surface and the straight path stretching to the horizon. The Roman roads are more than just ancient infrastructure. They are a testament to what humans can achieve when they combine technical skill with long-term vision. When they build not just for today, but for the ages. They remind us that true success is not measured in years or decades, but in centuries and millennia. And in that quiet moment before sleep, As you reflect on these ancient marvels, you might find yourself inspired to think about what lasting legacy you might leave for future generations. What roads you might build that will still be serving travelers long after you have become part of history yourself. The stones of the Roman roads have witnessed the rise and fall of empires, the birth of nations, and the transformation of the world. They have carried Roman legions marching to conquest, medieval pilgrims seeking salvation, Renaissance merchants pursuing fortune, and modern travelers exploring the past. They continue to serve, as they have for 2 millennia, as pathways not just across the landscape, but across time itself, connecting us to the remarkable people who had the vision to build roads that would last forever. The engineering brilliance of Roman road construction becomes even more remarkable when we consider the specific challenges they faced in different geographical regions throughout their vast empire. In the frozen highlands of Britain, Roman engineers had to develop techniques for building roads that could withstand the freeze-thaw cycles that destroy modern pavement. They discovered that by using larger foundation stones and creating deeper drainage systems, they could prevent water from freezing within the road structure and causing the devastating frost heave that plagues northern roads even today. In the Scottish Highlands, where Roman legions pushed the boundaries of their empire to the very edge of the known world, engineers faced terrain so challenging that even modern road builders approach it with trepidation. The Romans carved roads directly into living rock, creating passages through mountain ranges that seemed impassable. They developed techniques for blasting through rock using fire and cold water, heating the rock face with enormous fires, then suddenly dousing it with cold water to create thermal shock that would crack even the hardest stone. The process was incredibly labor-intensive and dangerous. Work crews would gather massive amounts of wood and build fires against the rock face, maintaining these fires for days until the rock was thoroughly heated. Then, in a carefully coordinated operation, they would douse the heated rock with cold water, often carried up from distant streams in leather buckets. The sudden temperature change would cause the rock to crack and split, allowing workers to remove chunks with iron tools and wooden levers. This technique, while effective, required enormous amounts of fuel and water, and the Romans had to establish supply lines that could keep the work crews fed and equipped in some of the most remote and hostile terrain in their empire. The logistics of these mountain road projects were staggering. Every tool, every piece of equipment, every scrap of food had to be carried up treacherous mountain paths by human porters or pack animals. In the desert regions of North Africa and the Middle East, Roman engineers faced an entirely different set of challenges. Here, the problem was not frozen ground, but shifting sand and extreme heat. The Romans developed specialized techniques for building roads across sand dunes, creating raised causeways that would remain stable even when the surrounding landscape shifted with the desert winds. They discovered that by creating a deep foundation trench and filling it with large stones, they could create an anchor that would prevent the road from shifting even when buried by sandstorms. They also developed techniques for protecting road surfaces from the abrasive effects of wind-blown sand, creating barriers and shelters that would deflect the worst of the desert storms. The heat of the desert presented its own challenges. Roman engineers learned to schedule construction work for the cooler parts of the day and to provide elaborate shelter and water supplies for their work crews. They also discovered that certain types of stone performed better in extreme heat, leading to the development of specialized quarrying operations in desert regions. Perhaps most remarkably, The Romans developed techniques for building roads across the great rivers of their empire. The engineering challenges of spanning rivers like the Danube, the Rhine, and the Euphrates were enormous, requiring the construction of bridges that could withstand not only the weight of traffic, but also the tremendous forces of floodwaters and ice. Roman bridge construction was an engineering discipline unto itself, requiring specialized knowledge of hydraulics, materials science, and structural engineering. The Romans developed sophisticated techniques for building bridge foundations in fast-flowing water using cofferdams, temporary watertight enclosures that allowed workers to excavate and build in dry conditions, even in the middle of a river. The construction of a Roman bridge typically began with a detailed survey of the river bottom and the surrounding terrain. Engineers would study the river's flow patterns, seasonal variations, and flood history to determine the best location and design for the bridge. They would also investigate the geological conditions on both sides of the river to ensure that the bridge approaches could be properly anchored. Once the location was chosen, work crews would begin construction of the cofferdams. These were typically built using wooden planks driven into the river bottom to create a watertight enclosure. The water inside the cofferdam would then be pumped out using human-powered pumps, creating a dry workspace where the bridge foundations could be built. The bridge foundations themselves were constructed using the same layered technique employed in road construction, but with additional features designed to withstand the hydraulic forces of flowing water. The Romans understood that moving water could create tremendous pressure against bridge supports, and they developed streamlined shapes and specialized construction techniques to minimize this pressure. The bridges themselves were typically built using stone arches, a structural form that the Romans had perfected and that could span large distances while carrying enormous loads. The construction of these arches required incredible precision and skill, as each stone had to be cut to exact specifications and positioned with mathematical precision to ensure that the arch would be stable and strong. The Romans developed sophisticated techniques for building these arches, using wooden frameworks called centering to support the stones while the arch was under construction. The centering would be carefully shaped to match the exact curve of the finished arch, and the stones would be laid on top of it, working from both ends toward the center. The final stone, called the keystone, would be placed at the top of the arch, locking all the other stones in place and allowing the centering to be removed. The precision required for this work was extraordinary. Each stone had to be cut to fit exactly with its neighbors, with tolerances measured in fractions of an inch. The Romans developed specialized tools and techniques for this work, including sophisticated measuring devices and template systems that ensured consistency across large construction projects. But Roman bridge construction was not just about the technical challenges of spanning rivers. The Romans understood that bridges were also powerful symbols of their engineering prowess and their ability to overcome natural obstacles. Many Roman bridges were built not just to carry traffic, but to impress local populations with the power and sophistication of Roman civilization. The famous Pont du Gard in southern France, for example, was built not just to carry water across the river valley, but to demonstrate Roman engineering capabilities to the local Gallic population. This magnificent structure, with its 3 tiers of arches rising 160 feet above the river, was a powerful advertisement for Roman civilization and a reminder of the benefits of accepting Roman rule. The Romans also developed sophisticated techniques for maintaining their bridges over time. They established regular inspection schedules and developed methods for repairing damaged stonework without disrupting traffic flow. They also created detailed records of bridge construction and maintenance, allowing future generations of engineers to understand the original design and construction methods. The integration of bridges into the Roman road system was carefully planned and executed. The approaches to bridges were designed to provide gentle gradients that would not strain the animals or vehicles using the roads. The Romans also built elaborate drainage systems around their bridges to prevent flood damage and erosion. The Roman road system also included sophisticated facilities for travelers and the movement of goods. The Romans understood that roads were not just about the physical infrastructure, but also about the services and facilities that made travel possible and comfortable. They developed a comprehensive system of way stations, rest areas, and supply depots that supported both military and civilian traffic. The mansions, or official rest stops, were spaced at regular intervals along the major roads, typically about 25 miles apart. A day's journey for a person on foot or a loaded wagon. These facilities provided accommodation, food, and fresh horses for official travelers, and they also served as centers for local administration and communication. The mansions were not simple roadside inns, but sophisticated installations that included accommodation for travelers of different ranks, stables for horses and oxen, workshops for vehicle repair, and storage facilities for supplies. The larger mansions also included baths, temples, and other amenities that made travel more comfortable and civilized. The Romans also established mutationes, smaller facilities spaced about 12 miles apart that provided fresh horses and basic services for travelers who didn't need overnight accommodation. These relay stations were essential for the operation of the cursus publicus, the Roman postal system, which depended on the ability to change horses regularly to maintain high speeds over long distances. The construction and operation of these facilities required enormous resources and sophisticated organization. The Romans developed detailed regulations governing the operation of way stations, including standards for accommodation, food quality, and service levels. They also established systems for supplying these facilities with everything from grain and wine to fresh horses and replacement equipment. The Roman road system also included sophisticated warehousing and storage facilities at key locations. These horea, or warehouses, were designed to store grain, wine, oil, and other bulk commodities that were transported along the roads. The Romans understood that efficient transportation required not just good roads, but also secure storage facilities that could protect goods from weather, theft, and spoilage. The design of Roman warehouses was based on the same principles as their road construction: durability, functionality, and attention to detail. The warehouses were typically built with thick stone walls, tile roofs, and raised floors that protected stored goods from moisture and pests. They also included sophisticated ventilation systems that maintained proper air circulation and prevented the buildup of humidity that could damage stored goods. The Romans also developed specialized techniques for loading and unloading goods at these facilities. They built raised platforms that allowed wagons to be loaded and unloaded efficiently, and they developed standardized containers and measuring systems that simplified the handling of bulk goods. These innovations made it possible to move large quantities of goods quickly and efficiently across the empire. The security of these facilities was also a major concern. The Romans built their warehouses with defensive features, including thick walls, limited entrances, and guard posts. They also developed sophisticated systems for tracking and accounting for stored goods. using written records and physical tokens to prevent theft and ensure accountability. The Roman road system also facilitated the development of a sophisticated commercial economy based on long-distance trade. The roads made it possible for merchants to transport goods across vast distances with reasonable certainty that they would arrive safely and on time. This reliability encouraged the development of specialized production centers that could serve markets throughout the empire. The famous Roman wine trade, for example, was made possible by the road system. Wine produced in the hills of Gaul could be transported to markets in Britain, Germany, or North Africa, with confidence that it would arrive in good condition. The roads also made it possible to transport the specialized containers, tools, and equipment needed for wine production, creating an integrated economic system that spanned the entire empire. The Roman road system also supported the development of sophisticated financial systems. The reliability of transportation made it possible for merchants to enter into complex contracts for future delivery of goods, and the standardized distances and travel times made it possible to calculate costs and risks with reasonable accuracy. This led to the development of banking and credit systems that facilitated long-distance trade. The Romans also used their road system to support the development of specialized industries in different regions of the empire. Areas with particular natural resources or manufacturing capabilities could specialize in producing goods for markets throughout the empire, knowing that the road system would allow them to reach customers efficiently. The pottery industry provides an excellent example of this specialization. The Romans developed large-scale pottery production centers in regions with good clay and fuel supplies, then used the road system to distribute their products throughout the empire. The standardized sizes and shapes of Roman pottery made it possible to pack and transport these goods efficiently, and the reliability of the road system made it economically viable to ship relatively low-value items over long distances. The Roman road system also supported the development of tourism and pilgrimage. The roads made it possible for people to travel for pleasure, education, or religious reasons, leading to the development of a travel industry that included guidebooks, maps, and specialized services for travelers. The Romans were among the first people to develop systematic approaches to what we would now call tourism. They produced detailed itineraries for popular travel routes, including information about distances, travel times, and available accommodations. They also developed guidebooks that described the sights and attractions along major routes, helping travelers plan their journeys and make the most of their time. Religious pilgrimage also became possible on a large scale thanks to the Roman road system. People could travel to important religious sites throughout the empire, knowing that they would find adequate roads and accommodations along the way. This led to the development of major pilgrimage routes that continued to be important long after the fall of the Roman Empire. The Roman road system also played a crucial role in the spread of ideas, culture, and technology throughout the empire. The roads made it possible for people to travel easily between different regions, leading to the exchange of knowledge and the development of a truly cosmopolitan culture that drew from all parts of the empire. The spread of Roman law, for example, was greatly facilitated by the road system. Legal scholars and administrators could travel throughout the empire, carrying with them the knowledge and precedents that formed the basis of Roman jurisprudence. The roads also made it possible for local officials to communicate with higher authorities and to receive guidance on legal matters. The Roman educational system also depended on the road network. Students could travel to study with famous teachers in distant cities, and scholars could travel to libraries and research centers throughout the empire. This mobility of scholars and students contributed to the development of a unified intellectual culture that transcended regional boundaries. The road system also facilitated the spread of artistic and architectural styles throughout the empire. Craftsmen and artists could travel to work on projects in distant regions, carrying with them the techniques and styles they had learned elsewhere. This led to the development of a distinctive Roman artistic style that incorporated elements from all parts of the empire while maintaining a coherent overall character. The Romans also used their road system to support the development of a sophisticated communication network that extended far beyond the official postal system. Private messengers, traveling merchants, and ordinary travelers all carried news and information along the roads, creating an informal but highly effective system for spreading information throughout the empire. This communication network was essential for the functioning of the Roman economy and government. Market information, political news, and social developments could spread rapidly throughout the empire, allowing people to make informed decisions about everything from business investments to political allegiances. The Roman road system also supported the development of a sophisticated military organization that could respond rapidly to threats anywhere in the empire. The roads made it possible to move troops quickly from one region to another, and the standardized construction techniques ensured that military equipment and supplies could be transported efficiently regardless of the specific route taken. The Roman military also developed specialized techniques for using the road system for strategic purposes. They established supply depots at key locations along major routes, and they developed rapid communication systems that could coordinate military movements across vast distances. The roads also made it possible to establish forward bases and staging areas that could support military operations in remote regions. The Roman road system continued to evolve throughout the empire's history, with new roads being built and existing roads being improved and extended. The Romans developed increasingly sophisticated techniques for dealing with difficult terrain and challenging conditions, and they incorporated new technologies and materials as they became available. The late Roman period saw the development of new construction techniques that made road building more efficient and cost-effective. The Romans learned to make better use of local materials and to adapt their construction methods to local conditions, reducing the cost and complexity of road building while maintaining their high standards for durability and performance. The Roman road system also influenced the development of urban planning and architecture throughout the empire. The roads connected cities and towns in a hierarchical network that reflected the political and economic structure of the empire. Major cities were connected by the most important roads, while smaller towns and settlements were served by secondary routes that connected to the main network. This hierarchy of roads influenced the growth and development of cities throughout the empire. Cities located on major routes grew and prospered, while those in more remote locations remained smaller and less important. The roads also influenced the internal layout of cities, with major streets often following the alignment of the roads that connected the city to the broader network. The Roman road system stands as one of the greatest engineering achievements in human history, a testament to the power of systematic planning, skilled craftsmanship, and long-term vision. The roads not only served their immediate practical purposes, but also created the foundation for a civilization that would endure for centuries and influence the development of the entire Western world. As you drift off to sleep tonight, Imagine yourself as a time traveler walking along one of these ancient highways, feeling the perfectly fitted stones beneath your feet, hearing the echo of countless footsteps from across the centuries. Picture the Roman engineers and workers who built these roads, their dedication to excellence, and their commitment to creating something that would last forever. In your dreams, you might find yourself joining that great procession of travelers who have used these roads across the millennia, each adding their own small part to the great story of human achievement that the Roman roads represent. Sweet dreams, and may your own journeys, whether on ancient Roman stones or modern highways, be as enduring and meaningful as the roads that carry you.